So we're working our way through this trig review sheet, or extra practice sheet, and we're up to number 4, solve for x. And so the idea here is that we may have to solve some of these kinds of problems, right, and try to put them together to solve for the bigger problem. So our first one is 2 cosine x plus 1 equals 0. So let's take a look. For a, we have 2 cosine of x plus 1 equals 0. So therefore cosine of x is minus 1/2, right? And so we're looking to see for what angle is the cosine of x equal to minus 1/2. So on the unit circle, the cosine is going to be the x coordinate, right? And so we have two possibilities here. One is here and one is here. And so do you remember where we had minus 1/2? So that would be the coordinate minus 1/2 square root of 3 over 2, right? And that comes from the 30, 60, 90 triangle. And so that's going to be then, which side is this? Well, we could just draw a quick little triangle here. So if this is pi over 6 and pi over 3, right, this is 1, 2, square root of 3. So if the cosine is 1/2, right, that means it's pi over 3. And so if I was over here, then I would have a positive 1/2, but then I'm flipping it over here to get the negative 1/2. So I have 2 pi over 3 is one answer. And then I also have the pi over 3 down here too, right? And so what's that one going to be? Let's see, that's 2 pi over 3, 3 pi over 3, 4 pi over 3. So it's 4 pi over 3. And of course we could add 2 pi to each of these values. So we could just say plus multiples of 2 pi if we wanted all possible solutions. Okay, but for us, we'll just take our solutions from 0 to 2 pi and assume that you can add multiples thereof. So part B was 3 cotangent square root of x equals 1. So that's cotangent squared equals 1/3. So that's cotangent of x equals plus or minus 1 over the square root of 3. And so that means that the tangent of x is plus or minus the square root of 3. Good. Now, where have we seen that before? You'll notice that opposite over adjacent here would give me a negative square root of 3. And so where would I get a positive? So we need to do those separately. Tangent of x equals the square root of 3, or tangent of x equals minus the square root of 3. So they're multiples of pi thirds here. We just need to get the right ones attached to the right ones. Good. So let's see, for plus the square root of 3 over 2, we would need, where's the tangent positive? The tangent is positive in this quadrant, where x and y are both positive, or cosine and sine are both positive, and it's also positive down here, and that's where both sine and cosine are negative. And so we'll have a pi over 3 here, right? And then this one will also be, so what's that one? That was 4 pi over 3. I think we did that one before, right? So that's 2 pi over 3, or 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. Good. So pi over 3 then, 4 pi over 3. Good. And then for negative square root of 3, we're either in this quadrant or this quadrant. And so in this quadrant, it's going to be 2 pi over 3. And then this quadrant is 2 pi minus pi over 3. What's that? 6 pi over 3 minus pi over 3 is 5 pi over 3. Good. And of course, then we could add multiples of 2 pi to these 4 solutions. There we go. Good. Part C, we have sine of x greater than cosine of x. Well, before we look at where they're greater, where are they equal? So we could actually look at two possible graphs, right? There's that graph, and then there's the graph of sine. We'll just draw one period. Cosine. Yeah. Okay, close enough. So you see we're looking for these angles between here and here, right? That's where the sine is bigger than the cosine. So where are those angles at? Well, at pi over 4, they're equal, and this one would be the other place where they're equal, right? Where's that? That's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Good. And so we can see that the y-coordinate is bigger than the x-coordinate from pi over 4 to 5 pi over 4. So therefore, x is between pi over 4 and 5 pi over 4. Good. And so then we could add 2 pi again to all these values to get another interval, but that's fine. We can stop there. Very good. All right. So that was number 4. And so number 5 is, there's going to be quite a few of these. So let's take a look to see what the deal is with all of these. We're just evaluating the inverse sine or inverse cosine of a bunch of numbers. And so the way to think about those, number 5, is that if I want to compute, for example, let's just take a look at the first one, the inverse sine of 0. Well, the inverse sine outputs the angle measure for which sine of theta equals 0. And so we know from our graph, right, either here or here, that theta equals 0 is our solution. Good. B, inverse sine of 1 equals, I'll just write this as equals theta, right? That's kind of my technique. And then we say for which the sine of theta equals 1. Where does the sine of theta equal to 1? Well, the sine of theta equals 1 at the top of the peak here, and so that's pi over 2, or you could think of it as here. So theta equals pi over 2. Now, can I add 2 pi to these? Actually, no. This inverse sine just outputs angles, the output. So let me draw that here, maybe. So the sine function looks like this. And so you'll notice that this is not one-to-one, so it does not pass a vertical line test because there's 2 intersections, or there's an infinite number. And so we have to restrict the domain of the inverse sine so that this is invertible. And so we just ignore the rest of the curve. And so when I say that the inverse sine of 0 equals 0, that's the only solution possible. Okay, and similarly, if we look for where this inverse sine of 1, or what is the inverse sine of 1, it's only going to be pi over 2. We're not going to be able to add pi. Good. Of course, we could add pi and do pi to that, but we're thinking like, if you were to punch this into your calculator, what answer would you get? You're only going to get one answer, right? Which one does the calculator output? It outputs this one. It outputs the answer between 0 minus pi over 2 and pi over 2. While we're at it, what does the sine or the cosine do? How do we restrict the cosine function? The standard restriction is to take this chunk right here, and so that would be from 0 to pi. Okay, and then ignore the rest so that the function is invertible. Okay, so one of those is coming up here pretty soon. Maybe we'll do another sine here. This is the inverse sine of 1/2. And so we call that theta, where sine of theta is 1 over 2. And do we remember the angle for that? Oh, it's actually up here. We've done it before. I guess we didn't do it in this video, so maybe we should do it again. So where's the sine equal to 1/2? Well, the sine is the y value, right? So the positive 1/2 is going to be here or here. But we know that we only want angles between minus pi over 2 and pi over 2, so that's only in these 2 quadrants. So we're going to ignore this one and just look at this one. And so if this is 1 over 2 for the y coordinate, the x coordinate must be the square root of 3 over 2. And so what angle does that refer to? Square root of 3 over 2 and the 1 over 2. That's x is longer than the y, right? So we can also do a quick little graph here. This is 1, 2, square root of 3, pi over 6, pi over 3. Right, so if we want the sine to be equal to 1/2, it looks like we're going to need pi over 6. Very good. Okay, we're about the 10-minute mark, so I'm going to stop here, and we'll pick up on number 5 in the next video.